Hey guys, in this video, I'm going to explain the difference between list and generator in Python. Lists and generators are both used to manage and manipulate collections of data, but they have some key differences in terms of their implementation, behavior, and use cases. The first one is evaluation. Lists are eager evaluation because lists are collections that can store all their elements in memory at once. When you create a list, all the elements are evaluated and stored in memory in a single variable. For example, let's define list numbers function. This function going to generate a list of numbers from 0 up to n. And I'm going to test the memory usage of this list with large numbers to compare the memory usage of generators and lists. Generators use lazy evaluation, meaning that they generate values on the fly only when requested. Elements are computed one at a time and not stored in memory all at once, like list in a single variable. For example, let's define a function that generates numbers. There is a keyword here that generates a generator of each number in a for loop in this function. It just computes one at a time and not stored in memory all at once. Okay, the second is memory usage. Based on these functions I have defined, I'm going to measure the memory usage of both lists and generators function with the same data. So in the memory usage, lists can consume more memory, especially for large data sets, as all elements are stored in memory in a single variable. For example, to measure the memory usage of the list function with large data, so in this case, I just used large number as input to the list function, and the memory usage of this function is these bytes, and I'm going to compare the memory usage of the generator with the same input data, and I can just copy this and just replace the function only to measure the memory of the generator. So this is 104 bytes. This is very small in memory usage. So the memory usage of generator is efficient than the list because lists can consume more memory, especially for large data sets. So in this case, I just use large data sets as an input, and but the memory usage is not efficient. The generators are more efficient in memory usage, especially for large data sets. Only one element is generated at a time. Okay, next I'm going to compare the processing time of lists and generate. So you can iterate over a list multiple times. So accessing elements is fast and direct in the list as they are stored in contiguous memory locations. Okay, let's test the processing time of the function with the same input number. So this is the times to process the list, and I can apply this for generators to compare the processing time of the list and generators, and we can compare that which is fastest way. So I can just as you can see, the list is fastest in the processing time than the generator because generator can be iterated only once. So once exhausted, they need to be recreated to start over. But lists are iterate over a list of multiple times, and accessing elements is fast and direct as they are stored in contiguous memory locations. So when you are comparing with the speed, list is the fastest than generator. And the other use cases are lists used when you need to access elements randomly, and when you want perform multiple operations on the data, for example, append, extend, remove elements from the list, because list has a rich set of methods to manipulate data. And when data set is small enough to fit in memory, that is also a use case to use lists than generator. But use generators when dealing with large data sets to conserve memory, because it is memory efficient than lists. And when you, for scenarios where you only need to iterate over the data once. So in summary, choose between lists and generators based on your specific requirements, considering factors like memory usage, lazy evaluation, and the need for random access or multiple operations in list or generators. I hope you find this tutorial useful. Don't forget to like, share, and subscribe. Thanks for watching today.